So in this tutorial I will show you how to make a prediction using the created profiles. So we have two profiles available, the full profile with a active cutoff of 10, and we also have the optimized bio profile that we used to narrow down and select a subset of the assays. So since that is the one that's more relevant to making predictions, we'll go ahead and select that as the profile we would like to use for generating predictions. And since we already uploaded a test set in our datasets tab, we have that available right here to make predictions on. Now if that data set has in vivo or activity data, you can the data will be displayed after the prediction made, so you can compare how accurate your profile is at making predictions. So we have more parameters to set under this tab than we did the profile tab. We have the minimum biological similarity to calculate nearest numbers. So this is a number between 0.5 and 1, which is a cutoff, a biosimilarity cutoff for to make a prediction on. So if a biosimilarity calculations falls below this threshold, a prediction will not be made. So we're going to leave that cutoff at about 0.5. And we also have a confidence parameter. That is the confidence of the biosimilarity calculations, where a compound that has a biosimilarity calculation that was used to with more active data, that was a biosimilarity calculation that had more active data used to make that calculation, will have a higher confidence than that one that uses only inactive data and not a lot of it, because there's a decent amount of missing data. So if two compounds only share a small amount of assays, the biosimilarity calculation compared to a biosimilarity calculation where the compounds have a significant amount, a lot larger amount of data, that value would be considered higher. And I refer the user to the website paper in bioinformatics to further explain the confidence value in the biosimilarity calculation. And then lastly, we can select the number of nearest neighbors to be used in the biological nearest neighbor calculation. So I'll select 3, so a biological nearest neighbor to use that as a prediction. So that means for every test set compounds, it will find 3 of its nearest neighbors in the training set, its biological nearest neighbors, and average those activities to make a prediction on a test set compound. So I'm going to go ahead and submit. And again, this is a long process, so I will pause. So after our compounds have been tested, predicted, you are able at the bottom part of the browser screen, a table will show up with listing the in vivo activity of your training set, as well as the biological nearest neighbors prediction on that particular compound. All of these data are available to download by clicking this link. We see here that an inconclusive prediction is 0.5, an active prediction is 1, and inactive prediction is 0. So for compounds that did not meet the biological nearest neighbor parameters that we set while making predictions, they will receive a prediction of NA. And all the predicted activities will be right in this column. And any compound that has an activity can be visualized in a biological similarity graph that I will show in the next video by clicking on the PubChem CID number for that particular compound. So we will go ahead and explore the compound, the prediction compound for PubChem compound 3136.